All right, in this video, we are going to basically review the entire of grade 10 factoring with 21 unique questions. Now, this video is not meant to teach you factoring. It's just meant to be a review either at the end of the chapter with some harder questions, or basically if you're reviewing factoring for your exam, or if you're going to grade 11, grade 12, and need a review of factoring before you start those courses. So let's take a look at the first example over here. In this one, I can tell that there's a common factor. Always try to look for a common factor in every single factoring question. Over here, my largest common factor is 2n squared p squared. And then I'm just dividing each term by that. So over here, I'll just be left with 2p plus 5n squared minus 6n. And if I make any mistakes in this video, feel free to let me know in the comments. So that one over there is completely factored because I can't factor the inside anymore. There's no trinomial over there, so that question is complete. Second question over here, I'm factoring this one. I have four terms. I'm factoring it by grouping, so I'm going to split it down the middle. A common factor, the left side, I'll have 4v times 4v minus 3, and over here, negative 3, 4v minus 3. So now I just write the insides and the outsides, and this is actually going to be 4v minus 3 squared because the brackets match in this one. Third example here, simple trinomial. I'm just doing my man method. So 1 multiplies to negative 10, adds to negative 3, it's just negative 5 and 2. So I'm just left with a minus 5, a plus 2. Fourth question here, there's a common factor, so you should note that first. We're going to common factor out the 2, left with d squared minus 11d plus 28. Now it's a simple trinomial inside the bracket, so I can do my man method. What multiplies to 28 and adds to negative 11? It's just negative 7 and negative 4. So I'll start by writing the 2. Then I just have d minus 7 times d minus 4, and that's my final factored solution. Fifth one here, again, this is a simple trinomial because there's no constant in the front. We just have two variables in this one. Same idea, I'm just doing my man method. So what multiplies to 18 adds to negative 11, it's negative 9 and negative 2. So when I write my solution here, it's k minus 9m and k minus 2m. Don't forget to include both letters like that. Next one here, again, this is a simple trinomial. It just has exponent 4, 2, and then 0. Again, I'm just doing my man method. What multiplies to 30 and adds to 11? It's just 6 and 5. I'm writing my solution here. It's x squared plus 6 times x squared plus 5. Now you would look inside the brackets to kind of see if you could factor those further, but this one you can't factor any further, so that is my final solution there. Make sure you have x squared and x squared because x squared times x squared gives you x4. Next one here, that looks pretty hard, but what you want to do is you want to just start with the substitution. Let a equal to x minus 5, and then you want to just rewrite this equation as 3a squared plus 27a minus 66. Then we want to factor this, so I can common factor out the 3. And then I want to factor this with my man method. Simple trinomial again. So 1 multiplies to negative 22 adds to 9. It's 11 and negative 2. So I can write this now in factored form, a plus 11, a minus 2. But the problem is not complete yet. I have to resub in the x minus 5 into this equation. So I'm replacing the a with x minus 5 in both brackets. And then we want to combine like terms inside the bracket. So I'll get x plus 6 x minus 7, and that is my fully factored solution over here. Eighth problem here. Now there's no common factor. It's a complex trinomial. I'm doing my man method again, but I have to factor by grouping. My m is 8 times negative 5, which is negative 40. My a is negative 6. So my numbers will be negative 10 and positive 4. So I have 8k squared minus 10k plus 4k minus 5. I'm going to factor this by grouping now. So 4k, 2k, oh no, 2k, not 4k, 4k minus 5. Over here, there's no common factor, so I'll just take out a plus 1, 4k minus 5. The brackets have to match here. The final solution, 4k minus 5, 2k plus 1. Again, no common factor here. We have two letters, but it's a complex trinomial. So I'll start with my man method. So 1 multiplies to negative 60 and adds to negative 7. That's negative 12 and 5. So 6c squared minus 12cd. Make sure you include both letters there. Plus 5cd minus 10d squared. I'm going to factor by grouping. Common factor here is 6c. Left with c minus 2d. Common factor here is 5d. Left with c minus 2d. So final solution is 6c plus 5d. C minus 2d. 10th question over here, what we notice is we have a common factor of 2 in all of these. So I'm going to common factor out my 2 first. Oops. And then this is a complex trinomial. I'm going to do my man method. So 4 times 6, my m is 24. My a is, oh no, that's a 3, not a 6. Before divided by 2. So my m is 12, my a is negative 8. So my two numbers are negative 6 and negative 2. So now I want to break this up into grouping. So 4k squared minus 6k minus 2k plus 3. And then I'll split this in the middle and factor by grouping. So common factor there is 2k. 2k minus 3. Over here, common factor is negative 1. 2k minus 3. Then final solution is 2 times 2k minus 3 times 2k minus 1. So that covers the first page of questions, and now we're just getting to the second page in this video. So again, looking at this first question here, I guess the 11th question in the video total. This is a complex trinomial. There's no common factor here, so I'm just doing my man method. My m is 10 times negative 12, which is negative 120. My a is negative 7. Larger numbers here, so you might need a calculator to figure this one out, even if it's possible. So let's see. 10 times 12 will now work. What about 15? 15 times 8, that's going to work. So negative 15 and positive 8 are my two numbers for this one. I'm going to break this down. M cubed n squared. Make sure the middle terms are the same as that there. Plus 8m cubed n squared minus 12n4. Now we'll split it down the middle and we'll factor by grouping. So over here, my common factor is 5m cubed. And I'm left with 2m cubed minus 3n squared. Over here, my common factor is 4n squared. Left with 2m cubed minus 3 and square. So brackets have to be exactly the same. So final step, I'll just write it in factored form. Okay, next one here again looks like a complex trinomial. I'm just going to start by saying let y equal to x plus a for this one. So I'm going to rewrite this as 2y squared plus 3y plus 1, and then I'll do my man method. So what multiplies to 2 adds to 3, it's just 2 and 1. I'll break this down now, and then I'll split it and group it. So 2y, y plus 1, plus 1, y plus 1. So 2y plus 1, y plus 1 is the factored form here, but this is not complete. I have to replace the y's back with x plus a. So 2 times x plus a plus 1, then x plus a plus 1. And then I just have to multiply this 2 into the bracket. And this is my final solution to the question. There's no combined like terms that I can combine there, so nothing else I can do there. Okay, let's go into the next question here. This is just a difference of squares, negative times square rootable terms. So it's just 10g plus 9, 10g minus 9. Pretty simple over there. Next one here, this looks like a difference of squares, but I can actually common factor out a 9 first. And then I can difference of squares the bracket. Oops. K plus 2, k minus 2. Next one here again is just a difference of squares but with 2 letters. So 5x plus 6y, 5x minus 6y. This one looks like a difference of squares, but again, there's a common factor here, and my common factor for these is 3. Now I can difference of squares it. And that is my final solution for that one. Next one here, this you may or may not be able to tell it's a difference of squares, but you want to just start by saying let a equal x minus 4. So now I can rewrite this equation as a squared minus 16. I can difference of squares this, a plus 4, a minus 4, and then I'm going to replace the a's back with x minus 4. Then I'll just combine like terms inside the bracket. So minus 4 and plus 4 just cancel. So I'm just left with an x here. Don't need a bracket anymore because it's just a common factor. And here it's just x minus 8. So that is my full solution in factored form. Next one here, again, I'm doing difference of squares on this. So the square root of y square over 81 is just y square over 9. And then here, this is just x square over 25 with a plus, and then y square over 9 minus x square over 25. And then we can never difference of squares a bracket with a plus, but this one can be factored even further by difference of squares again. So I'm going to just write the first bracket the exact same. This one I'm going to difference of squares now. I'll write it over 2 lines just because I can't squeeze it here. But if I square root this, I'll get y over 3 plus x over 25, and then the second bracket, which should be multiplied here at the end, it's just y over 3 minus x. Oops, that's not 25. Square root of 25 is 5. X over 5. So final solution is this times this times this. We have 3 brackets multiplying. We did difference of squares over 2 steps over there. Okay, next question here. This looks like a complex trinomial, but it's actually a perfect square. You could do it like a complex trinomial, but doing a man method it take extremely long to figure out the numbers because they're so huge. But if this is square rootable, this is square rootable, we can try perfect square. So square root of 25x square is 5x. Take the sign from the middle. Square root of 49 is 7. Put a square outside the bracket and then do your test. 5x times 7 is 35x, times 2 is 70x. So I know that perfect square works here because this times this times this gives me the middle term. Same thing over here. This looks like a perfect square. I'm going to try it and verify my answer. So square root of 9a squared b squared is just 3ab. Take the sign from the middle term. Square root of that is just 4cd. Put a square, and now I'll do my test. 3ab times 4cd is 12abcd times 2 is 24abcd. It's the exact same thing, so we know again this one works. And last question for this video, this over here is again a difference of squares, but we have to do two substitutions. So let a equal 3c plus 2 and b equal 3c minus 2 because the brackets are not the same. So I can rewrite this now as a squared minus b squared. I can factor with difference of squares, a plus b times a minus b. And now I can replace my a's back with 3c plus 2 and b's back with 3c minus 2. So here I have 3c plus 2 plus 3c minus 2. I don't need any double brackets because it's just a plus sign. But over here, I have 3c plus 2. And when I put the minus, I have to put the 3c minus 2 inside a bracket because that negative is going to distribute to both terms. Over here, I'll just combine like terms. Plus 2 and minus 2 cancel. 3c plus 3c is just a common factor of 6c. I don't need a bracket anymore. And then over here, I can distribute the negative into the bracket. So minus 3c plus 2. And then I can combine like terms. So 3c minus 3c just cancel out. 2 plus 2 is just 4. And then 6c times 4, that's just 24c. So my final solution to this question, fully factored form, is just 24c. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.